Hey guys, Mrs. Reba here, presenting our 2.7 open sentences notes to you in a video format. And something new based on some feedback I've been getting. Some people would like to have a little bit more information that I might be able to provide beyond the typed slides. So here we go. At any point in time during this video, you might decide that you need to pause, rewind, or fast forward the video in order to get more information, have more time for writing. I am limited in the amount of time I can record, so please feel free to pause, rewind, or fast forward as you go through. As always, you are expected to write certain things down, but if you'd like to write down more, you can. We're going to go ahead and take a look. Before we continue, I want to practice pausing, rewinding, fast forwarding before we get into the math content. So while you practice, I'll just go ahead and tell you a joke. Again, pause, rewind, fast forward. The joke of the day today is, what did the 0 say to the 8? Nice belt. You might want to take a visual on that if you didn't get it. It's pretty hilarious, I know. So taking a look, not only are we in a video format, but we've also included a learning target on the first slide here. Just to let you know, by the time you finish this, you should be able to find the value of a variable when it is used as an unknown in a simple equation or inequality. So as we take a look here, there's a warm-up for you to go ahead and practice. At this point, you should pause the video and make an attempt to mentally find a value of the variable that makes each statement true. And then for part 2, find 2 values of the variable that make each statement true. Go ahead and push pause and take care of that now. Hopefully, at this point, you have identified that a equals 15. If we take a look, we know that to be true because if we take our a and substitute a 15, it makes a true statement. 15 plus 3 equals 18. So we take a look at b. Hopefully, you have found that b equals 21. If we take our original equation and substitute 21 for b, we find out that 21 minus 3 equals 18, which is true. If we take a look at c, here we find that c equals 6. If we go ahead and take a look at substituting 6 in the original equation for the c, we find out 3 times 6 equals 18. Over here, if we substitute d equals 54, 54 divided by 3 equals 18. Part 2, a little bit different, asking you to find not one value or the value, but 2 values for the variable that make each statement true. If we take a look here, we've got a double inequality set up. 3 is less than x is less than or equal to 4. Since x is between the 3 and the 4, I know that values that work for x are also between 3 and 4. There are actually an infinite number of possibilities here. 2 examples would include x equals 4 and x equals 3.000001. This second solution here might clue you in as to why there is an infinite number of solutions. We can keep finding decimal places between 3 and 4 if we'd like to. Over here, 2 times y is greater than 10. Again, there actually are an infinite number of solutions here. 2 examples include y equals 5.001, where 2 times 5.001 is 10.002, slightly greater than 10, or y equals 100. 2 times 100 would give us a 200, which is of course greater than 10. Taking a look, this is our warm-up. If this went well for you, you're in luck because this is what it is. Let's continue on for some vocab. First, we are going to define a sentence. Since the title of the lesson is 2.7 open sentences, before we talk about an open sentence, it makes sense to know what a sentence in math is. Slightly different than a sentence in language arts. It is a combination of numbers, variables, operations, and a math verb. This right here is kind of the key word, math verb. We'll see a little bit more on that in just a moment. Sentences can always be true or false. Now here's where we're going to talk math verbs. If there are any of these that you don't immediately know as soon as you see it, you should copy it down into your notes. For example, there are 2 equation or equivalence verbs. The first one is equal to. A lot of you guys probably just say this is equals. The official language is equal to, and is approximately equal to. If our equal sign is wavy, that's saying it's not exactly equal, it is approximately or about equal to. We've got several inequality verbs. Is less than, is greater than, is less than or equal to, is greater than or equal to, and finally, my favorite of all, is not equal to. I think this is my favorite because it kind of reminds me of the Ghostbusters symbol, and I love the Ghostbusters. Open sentence and a solution. Now that we've defined sentence, we can define an open sentence and its solution. An open sentence is a sentence with a variable. An example would be 6 equals m minus 7. Can be solved to find a value for the variable that makes it true. In this case, to solve this, I would probably think about what the m was before it was subtracted by 7 and became a 6. Maybe add the 6 onto the 7, and I would find the solution. The value of the variable that makes it a true statement. In this case, m equals 13. I can always check my solution by trying out the 13 in place of the m. You'll notice the question mark here above the equal sign is me saying this isn't for sure true, I'm going to check it out. After I make my calculation, I can add the check mark and the equal sign because I know it works. Moving on to 2 additional examples. You should push pause now and try to answer these questions on your own before watching for the solution. Example A, find the solution to the open sentence, 52 minus p equals 40. Knowing what we know about math facts, we should be able to take a look at the numbers, look around, and find out that p actually equals 12. We can always check our answer, 52 minus 12 equals 40. And that is true, so we are okay to move on. In example B, to let enough light into a large room, a rectangular window must have an area of 112 square feet. You'll remember we talked about in class last time that areas are always measured in square units or units squared. If the base of the window is 8 feet and its height is h feet, write an equation that can be solved to find h. Again, from last time, from last year, from the year before, we have a formula for the area of a rectangle. Area equals base times height. If I substitute in what I know, that the area is 112 and that the base is 8, I can now look to see what would the height have to be to make this true. I think h equals 14. I used a division fact to find that actually, 112 divided by 8. If I check it out using my question mark, 112, is that equal to 8 times 14? Make the calculation and it turns out it is equal. Therefore, we are comfortable to say that h, or the height of the window, is 14. Taking a look at these notes, I hope you've been able to find some understanding, as well as perhaps find a place where you may have a question or two that we can discuss when I see you guys next week on Monday. Have a great day.